right, page 221. So we're going to do another example of summation notation for arithmetic summation notation. Two more examples actually, just to make sure I'm not repeating. Last one we did was the sum of 5n plus 3 for the values of n from 1 to 70. Alright, so we're going to do, bless you, find the sum of the series and we are going to find the sum of 2n minus 1. Sometimes it has a parentheses around it, sometimes it doesn't. It does not make a difference in the problem if you see parentheses or you don't. For values of n from 2 to 6. So far, n has always been a 1. Oh, we had n as 3, didn't we? Yeah, in that example, when you had to find out how many terms. So in this example, how many terms are we going to have? 2, 3, 4, 5, 6, right? Remember, it says to take your upper limit minus your lower limit and add 1. So 6 minus 2 is 4, add 1, you have 5 terms, right? These numbers aren't too very far apart, so you could just add second term, third term, fourth term, fifth term, sixth term, 5 terms. So we know that, 5 terms. Okay, so we have to find the sum of the 5 terms that we have in the series. The second term plus the third term plus the fourth term plus the fifth term plus the sixth term. So we use the formula for the sum of a series. We know it's arithmetic because this explicit formula right here is linear. We learned that last time. Today we're also going to talk about geometric series, and we'll learn how to tell the difference between when it's arithmetic and when it's geometric. So far we've only done arithmetic. We know it's arithmetic when the explicit formula is linear, okay? So, and that's important because our formulas are different. If it's arithmetic, we use a different formula than we do if it's geometric. If it's arithmetic, our formula is S sub n equals n divided by 2, open parentheses, a sub 1 plus a sub n. And remember, for this formula, we have to know the first term of the sequence. We have to know the last term, okay? So we use the lower limit to find the first term. We use the upper limit to find the last term. So that's what I do over here on the side. So I usually find my first term first. It doesn't matter which one you find first. But for the first term, I use my lower limit, which is 2. And remember, I just substitute it right into that explicit formula, the 2n minus 1. So instead of 2n minus 1, that will be 2 times 2 minus 1, which is 4 minus 1, which is 3. So my a sub 1 is 3. My first term of the series is 3. To find the last term of the series, I substitute in the upper limit, which is 6. And also put it right into that explicit formula, the 2n minus 1. So that'll be 2 times 6 minus 1, which is 12 minus 1, which is 11. So my a sub n is 11. Or you could think about it as your a sub 6 is 11, because that's the 6th term in the sequence. There's only 6 terms, so that's the last term, okay? Coolio. Remember, n is the number of terms. We already said what it was, but just so you have it in your notes to remember, the number of terms, your n, you take your upper limit, subtract your lower limit, and then add 1. So 6 minus 2 is 4. 4 plus 1 is 5. So n equals 5. So also what we could do, if we couldn't remember what this formula was and it wasn't given to us, we could literally just figure out what the first term is, the second term is, the third term is, the fourth term is, the fifth term is, and the 6th term is, and just add them all up, right? Because that's all that this is asking us to do. Add the 2nd, 3rd, 4th, 5th, and 6th term together. Well, we already know what the first term is. We already know what the 6th term is. If we just found the 2nd, 3rd, 4th, and 5th term, we could add them all up. Or we could just use this formula. That's all we're actually doing when we use the formula. So we're finding the sum of the first 5 terms. So we take n, which is 5 terms in the sequence, divided by 2, open parentheses. We take the first term of the series plus the last term. So that's 2.5 times 14, 35. We add those 5 terms together, we get 35. Easy peasy. You may have a question? All right, one more. Let me let y'all do this one on your own. Make sure you got it, because on your classwork today, you're going to have to do these by yourself. Find the sum of the series. We have the sum of 3n plus 2 for values of n from 3 to 6. What'd y'all get? What? 62? Bless you. That's what I got too. 62. 62. So I got that my first term was 11. My last term was 20. There were 4 terms in the series. Substitute it all in, and so those 4 terms added together, bless you, is 62. Any questions on that? Yes.
How do you get the number of terms?
Number of terms. Okay, so number of terms. You start with the 3rd term because that's your lower limit, and you're going to the 6th term. So you have the 3rd term, 4th term, 5th term, and 6th term. So when they're close, when they're not that many numbers, it's easy to count on your fingers, okay? But say you're going from the 3rd term through the 80th term, you don't want to count on your fingers. So the easy way to do it, take your upper limit minus your lower limit and add 1. So that's what I did down here on the bottom. Upper limit 6 minus lower limit 3 and add 1. Also, we did that in our notes. Last class, we did that at the bottom of page 219. We put that on there so you would have it, okay? Anybody else have a question about that or anything else? All right. So all of those examples, those 2 that we did today, plus the ones that we ended last class with, we did 4 last class, right? However many we did. Those were all arithmetic. So now I'm going to show you summation notation for geometric. And you're going to see the difference is this explicit formula looks different. It's not going to be linear. Everything else looks the same, but this is not linear, and the formula is different because we know that geometric series has a different formula than arithmetic series, just like the explicit formula is different for arithmetic than it is geometric. We already know the formula. We've used it already in previous classes. What page are we on? 222. It's a lot of notes, kids, we've taken this year. All right, so this is summation notation. For geometric. First example. Find the sum of the series. So we still have that sigma. The sum of 4, open parentheses, 1/2. So it's 4 times 1/2 raised to the n for values of n from 0 to 20. And sometimes you won't even have an n equals 0, it'll just be a 0 and a 20. If it has n equals 0 or just 0 down there, it doesn't make a difference, it's the same thing. Okay, so see how this is not linear, right? We have our variable is in the exponent. Well, we just had a whole test over that. Well, before unit circle, we had a test over variables in the exponent, and we know that's called exponential. When your variable's in the exponent, that's not linear. Whenever your variable's in the exponent. Linear is when your variable has a highest degree of 1. Your exponent's 1 of the variable. This is exponential. So that means that this is geometric. Okay? This would make a geometric series. If we had the numbers written out, like 2, 4, 8, 16, like I was multiplying times 2, geometric. Of course, we're going to write that out. This is a geometric series because it is an exponential expression. In parentheses, I'm going to put the variable is in the exponent. Okay, so they want us to find the sum of the series. So 0, if I substitute in 0 for n, all the way through 20, I have to add that up. So if I substitute in 0, 1, 2, 3, 4, all the way through 20. So since it's geometric, the sum of a series for geometric, it has a different formula. So let's write that formula out and see what we need to know to be able to do that formula, evaluate that formula. So that's S sub n equals A sub 1, open parentheses, 1 minus r raised to the n, close parentheses, quantity divided by 1 minus r. Bless you.
Thank you.
You're welcome. I just like to write down how to say it. A lot of times in math we don't know how to say things correctly. So, okay, so we know a sub 1 is our first term. So we have to find our first term. So we know that's our lower limit, just like it was in arithmetic. R is our common ratio. Lucky for us, this is really easy to find in this explicit formula, so I'll tell you how to find that. And then we need to know what n is. And n is just our number of terms, which we know how to find that is just the upper limit minus the lower limit plus 1. So that's easy to find as well. Okay? So like in arithmetic, we have to find the first term, the last term, the number of terms. In geometric, we have to find the first term, the common ratio, and the number of terms before we can substitute it into the formula. Okay? So I'm going to do all that over to the side. My first term, what do we substitute in to find the first term? 0, right? Lower limit. And when I say substitute in the lower limit, substitute in the lower limit into the explicit formula. That kind of didn't flow. I'm talking about the explicit formula that's provided, okay? This is the explicit formula that they already derived. So 4 times 1/2, where you see an n, I'm talking about, that's 0. So what's anything raised to the 0 power? 1. Awesome, except 0 raised to the 0 power is undefined. But anything else raised to the 0 power is 1. So 1/2 raised to the 0 is 1. 4 times 1 is 4. So my a sub 1 is 4. My first term in this series will be 4. I don't need to know my second term, third term, fourth term, fifth term, sixth term. I don't even need to know my last term for geometric like I did for arithmetic, okay? I do need to know how many terms are in the series. Well, we know how to do that. To find the number of terms, and I know we know how to do this, but I'm just going to make my notes complete. To find the number of terms, which is my n, take the upper limit and subtract the lower limit then add 1. Every time, add 1. To find the number of terms, which is n, take the upper limit, subtract the lower limit, add 1. So my upper limit's 20, minus my lower limit is 0, then add 1. 20 minus 0 plus 1 is 21, therefore n is 21. Now you have to know what the common ratio is, which is r in our formula. So easy to find r. Basically, it's given to us in the explicit formula. In the explicit formula, the base, meaning whatever the number is that has the exponent, that's the common ratio. Okay, so if my first term is 4, I multiply by 1/2 to get the next term in the series. Multiply by 1/2 to get the next term in the series. Multiply by 1/2 to get the next term in the series. Okay, so that's easy. So we're going to write it though. To find the common ratio, which I'm going to put in parentheses r, it is given to you in the explicit formula. It is the base. So in this case, we have 4 times 1/2 raised to the n. The base is 1/2. That is our common ratio. R equals 1/2. Or you could say 0.5, because we have this fraction to deal with, so if it makes it easier for you to call it 0.5 in these notes, call it 0.5. So you have to know those 3 things in order to find the sum of the series. Easy enough. Anybody have questions? Okay. So I am looking for the sum of the first 21 terms of this series, starting with term 0. So I'm looking for S sub 21. To find that, I take the first term, which is 4, open parentheses, 1 minus common ratio, which is 1/2. And I'm thinking it might be easier to just call that a 0.5. And I'm going to be really careful about my penmanship because that's going to mess me up with all these parentheses and decimals and whatnot. Raised to n, which is the number of terms in the sequence. In this case, that's 21. And 21 is inside the big parentheses, okay? Only the common ratio is being raised to the 21st power, not everything inside the parentheses. So be careful about that. That's a common mistake. All over 1 minus a common ratio of 1/2 or 0.5. Everybody cool? So, sum of 21 terms equals 4 open parentheses. I'm going to figure out what 1/2 raised to the 21st power is. 0.5 raised up, not divided by, to the 21st power. Okay, do y'all know what that means? When you see that on your calculator? Does anybody know what that means? It means I have to move the decimal 7 places. When it's negative, do I go 7 to the left or 7 to the right? To the left. 7 to the left. So it's getting smaller, 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 correct? If that was E and it was a positive 7, it would mean 7 to the right. So I could go ahead and write that out and do 7 to the left. But what I might want to do is I might just want to try to put this all in my calculator at the same time. Not the 4 times, because I don't want to get too crazy, but 1 minus 0.5 raised to the 21. Let me try that and see what I get. 1 minus, I'm going to do parentheses, although I don't think I need to. 0.5 raised to the 21st power. And that's what I got when I did it before. So 1 minus 0.5 raised to the 21st power over 1 minus 0.5, that's like 1 minus 50 cents is 50 cents or 0.5. I'm going to leave that in my calculator and multiply times 4. And I'm going to go 3.9999. Divide that by 0.5. And sum of the first 21 terms. So I'm going to say that is probably 8, because we rounded. So if we wouldn't have rounded, if we wouldn't have changed that to a decimal and left it at 1/2, we probably would have gotten 8 instead of 0.999999. You know what I mean? Everybody cool with that? All right, the next one will move quicker because we don't have to write all these explanations out. I have 2 more and then I'm finished with you. Well, besides your little classwork assignment. Anybody have a question? Comment? Concern? 223. If you need my book after notes, you're welcome to borrow it if you need to catch up. If anybody missed the unit circle quiz, make sure you see me ASAP to make that up. I'll be here till 2:40. You can come at lunch as well. But we need to get those made up. They are 65 points. Find the sum of the series. The sum of 2/3 raised to the n minus 1. Now last time you had a number in front of the, what was it, the base? This time you don't. That doesn't matter. This is still exponential, okay? For values of n from 1 to 4. worse, arithmetic or geometric? Geometric. Because that's definitely not linear, it is exponential. So when we find sum, we don't use the explicit formula. Explicit is when you're trying to find a particular term in a sequence. Sum of a series is when you're adding terms of a series. And if it's geometric, we use the formula S sub n equals a sub 1, open parentheses, 1 minus r raised to the n, divided by 1 minus r. We know we need to find the first term, the common ratio, and how many terms that are in the series. So let's find the first term. To find the first term, we substitute in the lower limit, which is 1, right? Into our explicit formula. So that would be 2/3 raised to the 1 minus 1, which is 2/3 raised to the 0, which is 1. So basically our a sub 1 is 1. Well, that's easy enough. Even if I would have converted that to a decimal, 0.6 repeating or 0.67 raised to the 0, I'd still get 1. We need to know our common ratio. What is it? 2/3 or, yeah, 0.67. It's the base in our explicit formula. We need to know n, the number of terms. Is it 4? We take the upper limit minus the lower limit and add 1. 4 minus 1 plus 1. Yes, it's 4. Y'all want to try to leave this as a fraction? I mean, we have a calculator. Sure. Okay, we'll just use a calculator and see what we get. So we're looking for the sum of first 4 terms of the series. So we take our first term, which is 1, times 1 minus the common ratio, which is 2/3 raised to the 4th power. Now remember, it's not negative 2/3 raised to the 4th power. It's only the common ratio raised to the 4th power. So make sure you don't do negative 2/3 raised to the 4th power. You got to be careful about that. All over 1 minus the common ratio of 2/3. So let me just see what 2/3 raised to the 4th power is. Is that going to give me a scientific notation thing like it did in the last one? It's a fraction, so I'm going to have to use parentheses. So open parentheses, 2 divided by 3 represents 2/3 raised to the 4th power. Can't see that. So let me just, if I do 1 minus 2/3 raised to the 4th power, that would be 1 minus, open parentheses, 2 divided by 3, close parentheses, raised to the 4th power. Again, I can't stress enough how important it is that you put this in your calculator correctly. So 0.8025, that's this, all of the parentheses, and then I'm multiplying times 1, so that's not going to change anything. All over 1 minus 2/3. So 1 minus, if I don't use parentheses and do it like that, well, in this case I get the same thing. Sometimes it just depends on the problem. I would just use parentheses just to make sure. Okay, but the denominator is 0.3 repeating. So 0.8025 divided by 0.3333, and you get approximately 2.4077. Which, as a fraction, that would represent 2,675 over 1,111. You want to know? So I said 0.8025. Other day I was going to show y'all the one we were doing, but I couldn't get it to. It wouldn't do it in my calculator, and I don't know why. So that's why I didn't bring it up. So I did it first before I showed you. So there's the decimal, right? So if you go up to math, option 1 is fraction. So if you just put enter, since it's already on option 1, you'll get that on your screen. If you put enter one more time, it will give you the fraction form of the decimal that was your last answer. You're welcome. Julio? Oh. Okay, I'm doing one more only because this time I'm going to give you a series and I want us to write the summation notation given a series. Okay? We did that on arithmetic. We started with that and then we did this, but so far for geometric, I haven't showed you how to be given a series and then write summation notation, and then we'll be finished with the notes. Any questions? All right, so anyway, if we would have converted this to a decimal to begin with, we would have gotten the same answer or close. We would have, just depending on where we would have rounded. So we have a calculator, we can use fractions. Just be careful with your parentheses. No, I'm repeating myself. It's what I do. 224. Given a series, write in summation notation. One comma. Two comma. 4 comma. Dot dot dot. 64. Is this geometric or arithmetic? Geometric. So geometric means we're multiplying by the same number each time. What are we multiplying by? Okay, so it's geometric. So we have to use the geometric formulas, right? All right. So, first thing we're going to do, to figure out the upper limit, so we got to figure out how many terms are from 1 to 64. How many terms is that if we are multiplying by 2? To figure out the upper limit in the series, comma, use the explicit formula and remember, there's an arithmetic explicit formula and there's a geometric. So since this is geometric, you got to make sure you're choosing the geometric explicit formula to find n. Substitute values for a sub 1 and r, comma, then solve for n. Do I need a comma after then? No? No? I feel like I do. So the explicit formula for geometric is a sub n equals a sub 1 times r raised to the n minus 1. I should have probably said substitute values for a sub 1 and r. Let me add this, and a sub n being the last term in the series. So we know our last term is 64 equals, our first term is 1 times, the common ratio is 2 raised to the n minus 1. And we're trying to solve for n. How many terms are there in the series? Okay, so we've done this before. Our variable's an exponent, so we can try to write both sides with the same base, or we can do logarithms. So if I divide both sides by 1, it's not going to change anything, right? I still have 64 equals 2 raised to the n minus 1. Now, I think I can write both sides with a base of 2, but let's just write it as a logarithm. That's going to be log base what? Log base 2 of 64 equals n minus 1. Of course, we do change a base. So change of base is log, what number do we put in first? 64, and then we close parentheses, divide by log of 2, and that is 6. So 6 equals n minus 1. Add 1, n equals 7. So our upper limit is 7. There are 7 terms in the series. Okay, now we need to figure out what the explicit formula is. Now we use this explicit formula to find out how many terms there are, but we need to use the explicit formula where we just substitute in our first term and the common ratio, but we don't want to substitute anything for n. Okay, we did this before with arithmetic. This part's kind of the confusing part. So just trust me on this one. We have to find the explicit formula specific to this problem substitute a sub 1 and r, simplify where possible, and that's it. So the formula is a sub n equals a sub 1 times r raised to the n minus 1. We just use that, okay? And remember, in the summation notation, we just use what's on the right side, okay? It's kind of like our formula telling us what to do. So our first term is what? Oh, sorry. 1 times 2 raised, I am slowing down, raised to the, but we're not plugging anything in for n, okay? We're just leaving n minus 1. We're only substituting in a sub 1 and r. Do I need that 1 there? No. So basically we just have 2 raised to the n minus 1. Now for our lower limit, we're always just going to use 1 unless they tell us otherwise, okay? We're going to go from our first term to our 7th term. If they said our lower limit's something different, then we use that, and they didn't. So we have everything we need. We're going to find the sum two raised to the n minus 1. That's what we found here. Okay. For terms of n from 1 to what? 7. And that's it. So if I wanted to find the sum of those terms, then I would have to go find the first term, or do what we did before. Find the first term, common ratio, how many terms were in the series, and use that other formula. But this is just me being given the series and writing it in summation notation. Does that make sense? So we do something totally different. Anybody have questions about that? Easy. When you have the directions. Takes practice on a couple of them, and then no big deal. But sometimes you gotta have the notes in front of you for a couple of times before you get the hang of it. All right, anybody have questions before I stop this? Okay.